In this video, we're going to use a couple of properties of orthogonality to prove a fact about a certain pair of vectors. So we're told that the vectors u plus v and u minus v are orthogonal to each other, or from a geometric perspective, that would mean they're perpendicular to one another. If those two vectors are orthogonal, then it must be the case that the two individual vectors, u and v, must have the same magnitude, must have the same length. All right, so we're being told that u plus v and u minus v are orthogonal. We have a condition that gives us exactly when two vectors are orthogonal, and that has to do with the dot product. Since those two are orthogonal to one another, their dot product must be 0. So now we can use properties of the dot product to simplify on the left-hand side. And essentially here on the left-hand side, remember that we can distribute using the properties of dot product. Dot product distributes nicely over vector sums and vector differences without any issues. It's like foiling, if you will, if you like using the word foil rather than distribute. All right, so when we distribute, we'll have u dotted with u. Notice we do not write that as u squared. These are vectors, so u squared has no meaning. Okay, we write it as u dot u. We have u dotted with a negative v, so that's the same thing as minus u dot v. We've got a v dotted with u, so we got a plus v dot u here. And then we've got a v dotted with a negative v, so we've got a minus v dot v. So that's just using the distributive property of the dot product with respect to vector sums. Now, another property that we know is that the dot product can be done in either order. So here I had v dot u, I can rewrite that as u dot v without any issues. And the reason why I might want to rewrite that as u dot v is because I've got a plus u dot v here and a minus u dot v here. So those two terms are going to go to 0. So we're just left with u dot u minus v dot v is equal to 0. Moving the v dot v to the right-hand side and then recognizing, oh yeah, when I dot a vector with itself, I get the magnitude squared or the norm squared. So I've got magnitude of u squared equals magnitude of v squared. And then we take the square root of both sides. Now, typically when we take square roots of both sides, we get plus or minus. But these are lengths of vectors, so they are not negative. I'm thinking of these as non-zero vectors, but these, I suppose they could also be 0 here, but still the same thing would apply. These are positive values, or at least they're non-negative values. So I don't have a negative, I don't get plus or minus here. I really do just get that they have to be equal to each other.